So hi guys, so welcome to the next lecture of competitive programming. So what next we will be doing is we will be learning about something called as prefix system. Okay, so let's go through the question. So you are given a list of n numbers and q queries. Each query is specified by two numbers I and j, and answer to each query is the sum of every number between the range I comma j. So what it is saying is basically, let's say you have an array. Let's say you have an array, right? So let's say you have an array, and let's say q queries will be given to you. So what will happen is, in query two values will be given, I and j. Let's say the first query is 3 comma 6. Now what will happen is, what you have to do is, what is this paper stuff? Okay, just wait a second. Yeah, I need to type this again. Okay, so basically what this 3 comma 6 means is, from third index till sixth index we need to return the sum, right? From this third index, let's say 0, this is 0 1 2 3. From third index 4 5 6 till seventh index we need to return the sum, that is this thing, right? So this is what this cumulative sum query problem is about. So let's talk about it, and let's talk about what are the possible solutions. So we will be given an array and of size n. The size of array will be, let's say, n. And let's look at the constraints. So n could be of 10 raised to power 5. N could be of 10 raised to power 5, of the order 10 raised to power 5. So we will be having an array. Then we will be having q queries, and the q could be of 10 raised to power 4. Q could be of 10 raised to power 4. So it is simple as that. Let's talk about the brute force. So basically you will take integer n, you will declare an n, then you will take the size of array as input, right? Then what you will do is, you will declare another variable q. You will take c in the q. Then you will run a while loop q times, and what you will do is, for every query you will declare two variables, let's say I and j, and you will see in I and j, and then you will run a for loop from, let's say, int k equal to from I to j. And inside each and every for loop, what you will do is, let's say you declare another variable, let's say sum equal to 0, and then you will increase the value of sum plus equal to air of k, right? So basically what we are doing is, let's say if this is I, if this is j, this is I, this is j, then if a query is given from I to j, we will iterate through I to j for each and every value, and we will add that value to the sum variable, right? So that is the brute force approach, right? That is the brute force approach. Now what is the problem with this brute force approach? As simple as that, these operations are negligible, right? These operations doesn't matter at all. But if you see this while loop, the q is of the order 10 raised to power 4. This while loop will run about 10 raised to power 4 times. The inner for loop, the maximum range of I and j could be like the size of array. There is a worst case possibility that I is 0th index and j is nth n minus 1th index, and all the queries of this are of size n, right? So let's say, then this, in the worst case, then this loop will run for 10 raised to power 5 times. And so if you multiply both of these things, so it will be approximately equal to 10 raised to power 9. And we know that in c++, in 1 second c++ can perform about an approximately 10 raised to power 7 operations, right? If it can perform 10 raised to power 7 operations in 1 second, it will perform one operation in 1 upon 10 raised to power 7 seconds, and it will perform 10 raised to power 9 operations in 1 upon 10 raised to power 7 into 10 raised to power 9, that is 100 seconds, right? So it will perform this whole thing in 100 seconds. But we have the time limit of 7 seconds. We have the time limit of 7 seconds here, you can see, right? We have the time limit of 7 seconds, you can see. So obviously what will happen, it will give us the TLE. So it will give us the TLE, time limit exceeded, right? So now let's talk about how we what we can do, right? Let's talk about something. Obviously we will be fighting for time and memory. We will, in competitive programming, in each and every algorithm we will be learning like throughout the sessions. So it will be all about the fight about time and memory. Okay, so in this case also let's try fighting for the time and memory. So one thing that we can do here is, what we can do is, let's say we have our original array. Let's say 1 3 4 5 6. Let's just take a random example. Let's do one thing, let's create a prefix array. Okay, so what this prefix array is, let's say for first position we will keep the value same. For next index, what we will do is we will add this 3 to the previous index, so it will become 4. Then I'll add this 4 to the previous index, it will become 8. Then I'll add this 5 to this 30, then 19, then 26, then 34, and in a similar manner we can create a prefix array. So what this prefix array is, at ith index of this prefix array we have the sum of all the elements. We have sum of all the elements from 0 till I. So this, what did this 13 is, this 13 is nothing, this 13 is nothing but similar to a query 0 comma 1 2 3 0 comma 3. It is sum from 0 to 3. Similarly this 26 is similar to a query 0 comma 5, right? So this is similar to a query 0 comma 5. So basically we do created a prefix array in which we are saving the sum till that particular index, right? Now let's say we have a query I comma j, in which we let's say we need to start from any ith index and we need to go till a jth index. So what we will do is basically we can say prefix. If we find the prefix of j, then this is the sum from 0 to j. This is the sum from 0 to j. So if I just erase some stuff, okay, it's not erase, yeah, it's erasing, yeah. So for j, prefix of j means sum from 0th index till this jth index, right? This much. And let's say this is my ith index, and similarly prefix of I means sum from 0 to this much, right? What if I subtract from this complete this much sum from this complete sum, then I will get my required sum, right? Then I can simply subtract this thing. So, and also I need to do a I minus 1 because I need to include this 8, right? So I need to do a minus 1, prefix of I minus 1. So it will just subtract this much part from this complete part so that I can get this much sum, right? So now let's try writing the algorithm for this one. Let's try writing the algorithm for this one. Let me erase this much stuff, right? So what will happen is, so first of all again we will take c in, like we will take n, the q and all those stuff, we will take q. Then we will run a while loop q times. We will run a while loop q times. Then we will see in my I and j, I'll see in my I and j my queries, right? uh, before that taking my queries as input, what I'll do is I will do some pre-computation. Right? In our pre-computation, what I'll do is I'll prepare my prefix array. So I will declare a prefix sum array of the size n minus 1, or you can say of the size n. Now what I'll do, I'll simply run a for loop. In my for loop, what I'll do, this for loop will run uh, from int, let's say I equal to 0 to n minus 1. And what I'll do is if I equal to 0, then air of 0, prefix of 0 will be equal to air of 0. Else for all the other cases, what I'll do is prefix of I will be equal to prefix of I minus 1, prefix of I minus 1 plus air of I, right? So what I'm doing is, let's say if I want to calculate this 8, prefix of I minus 1 is 4, prefix of I minus 1 is 4. Inside this 4 I will add air of I, that is this 5, right? Yeah, sorry, this 4, so it will become 8, right? So the current element, I will add the current element to the previous prefix's some value, right? So I will get the current element. So this way I will prepare a prefix array. So this loop basically will run for n times, right? And again we have, let's say, q queries, so that is 10 raised to power 4. So here we need to simply do a c out, and in c out I will say pre of j minus pre of I minus 1, as simple as that, nothing much. So this is done. So when we run two loops parallelly, we will add the operations, right? So this will be almost equivalent to, let's say, 10 raised to power 5. So that will be lesser than 1 second. So our TLB will go away. Obviously our TLB will go away. So that is all about the prefix sum algorithm. You can obviously try writing our code. Let's code right now for the same. So let's code. Let me clear the console as well. So as simple as that, what we need to do, first of all, let's declare n, then let's declare an array of size n, then let's take our array as input. So for int I equal to 0, I less than air dot size, I plus plus, and I'll take c in air I. So I'll take my array as input. After that, let's declare q, int q, and then let's say c in q, and then while q minus minus. What I want to do, I will, let me declare int I comma j, c in I and j, and then c out pre of j minus pre of I minus 1, right? As simple as that. And before that, let's declare an pre array. Let's declare an pre array that will be of size n again. And for pre array, what I'll do is, again I'll run a for loop, and I equal to 0, again I less than pre dot size, or we can simply use n here because we have the size in n, I less than n, and I plus plus, and so I'll add a simple if condition here. If I equal to 0, just do simply one thing, pre of I equal to air I, otherwise what we need to do is else what I'll do is, pre of I will be equal to pre of I minus 1, I minus 1 plus of the current element from the array. So yeah, that is it. That will be all about the code. And I don't think so I need to write the brute force as well. Let's say if we need to write the brute force as well, let me show you the brute force also. So instead of this thing, what we will do is, we will run a for loop. Let's say int k equal to I, k less than j, k less than equal to j, and k plus plus. What I need to do is, I need to declare a sum variable. Let's say int sum equal to 0, and then I'll simply say sum plus equal to air of k, and then in the end I'll see out my sum, right? So that will be my brute force, this is my brief computation, and that is the all about. Okay, so we'll see you in the next lecture with a new concept, new algorithm. Stay tuned. Thank you so much. Okay, then we'll see you in the next lecture.